All right. I think it's time for us to get started in here. Okay. Good morning. Good morning, everyone. This is our week 2 Thursday class. Okay. A few things to announce. Number one, we have a quiz tomorrow, quiz 2. So make sure you prepare for the quiz. The quiz will cover mostly the stuff we covered during lectures. Okay, that's the first thing. Second thing is our PA2 is still this Sunday. Make sure you work on it. Okay. And also I ported our lab 1 as well as PA1 from EdStem to Canvas. So you can see your updated grade a little bit. Okay. Are there any questions before we get started? Those are the announcements I have here. Go ahead. If you have questions, go ahead.
Is there any way that the quiz for the PA answers can be released just to check what we got wrong?
Okay. Let me see. Let me see the quiz. PA. All right, so there's another question. So for the PA quiz, let me see. So for PA1, let me check out the README questions. Right? Let me see if we have released it. PA1 scheduled release quiz solutions. Okay, I think I just released the quiz 1 solution, so it's there. Okay.
Thank you.
Another question is, you want to request a regrade. All the assignments are auto-graded. So in other words, there is no person who graded it. But if you have questions to say, why did I lose these points? You can go to the tutors and ask for clarification. Okay. There's no person graded the work. So you can just go to tutors, ask why you lose those points or which tests you failed, and then we can tell you why you lost those points. Okay. Any other questions? All right. So let's get started with the materials for today. Last time we were looking at how to get started with a project, but there was one exercise that we couldn't finish. It was the two-sum exercise, right? So the idea is you're given a list and you're given a t. This t is called the total. We want students to print out pairs whose sum equals to this total, like 1, 9, and 3, 7. So it's possible that there are several pairs that will be printed out. So the order of the printout doesn't matter. Okay. We don't want to have duplicates. In other words, you don't want to print out 1, 9 many, many times. Okay. The question is, how do we do this? How do we do this? You are given the list and your job is to print out all these pairs. Okay. Assuming the assumption that you can assume is there are no duplicates in this list. In other words, every number in this list is unique. That would make your life much easier. Okay, so that's the assumption you can make. We can work on this exercise a little bit as a warm-up. So here's the the link to the coding challenge. So I'll give you some time. Can you write a code that would print out these pairs? Okay. Give me a vote once you are done with the exercise. Then we're going to work on it together. Okay. No one is done yet. Okay. You can write the function or you just write the code itself. Either way is fine. Okay. But you are given the list, you're supposed to print out all the pairs whose sum is t. I would say probably having a function is better. No one is done yet. I'll give folks another 2 minutes, and then we'll work on this together. You need some sort of nested for loop. If you are done, give me a vote. I know you are done. All right, so it looks like this one is tricky, huh? Let's write this function, right? We'll print out all the pairs. So this one just print, so there's no need for me to return anything. So let's define this function. I call this toSum. And then this one would take a list, take a t, right? That's what we have. Now, what's the idea? The idea is if you're looking for two values add up equals to t, In other words, I need to find out all possible pairs. If I can do that, I can solve the problem. And in this example, we're assuming the list is small, right? If the list is big, then you got to use some other approaches. But if the list is short, I can generate all possible pairs, which just select 2 out of n, right? If n is the length of the list. The way you can try to think about it is each for loop would give you an index. So you need to find 2 locations. That means you need to generate 2 indexes. So all you need to do is to do the following for loop for I in range of, let me find out the length. N equals to the length of nums, right? So I would go from 0 all the way to the end. Now, how about the other list? The other location, you can say, well, it's also n. But the issue is, it's possible I and j are the same, and you may have the idea of I equals 1, j equals to 5, and j equals 1, I equals to 5. In other words, you're saying 9, 1 and 1, 9. You may print it out twice. So it's better that you say j goes after I. So you're looking at ordered pairs. If you look at this example, you're going to generate 0, 1, 0, 2, 0, 3, 0, 4. And then 1, 2, 1, 3, 1, 4, and go on. So by doing this, you don't have duplicates, and all you need to do is to check if nums I plus nums j is the same as t. I'm going to print it out. Print nums I, nums j. That's it. This function doesn't return anything. So I can say to sum, I'll give you the list 1, 3, 7, -1, 9, and say the total is 10. If I run it, Python to sum is going to print out 1, 9 and 3, 7. Any questions about this exercise? So it's one of the applications of nested for loops. So just imagine each for loop would give you a location in the list or in the string. If you need 2 locations, then 1 loop inside another loop. All right. Are there any questions before we move on? So this is like a warm up. All right. So we are done with nested for loops. Now it's time to move on to the main topic for today. The main topics for today is number 1, we'll look at the memory models. The second topic is debugging, how to debug our program. Memory models is kind of the idea that you look at a piece of code, in your mind, you know how the code would behave. In other words, you are like a human computer. Like you look at the code, in your mind, you can clearly execute the instructions in there, and you can predict the outcome. That is the idea of memory model. So basically, it tells you how the program is executed, the details in program execution. Okay, so it's a very important skill that we all know how to analyze the programs. So the first topic, we have a lot of details that we'll cover today. The first thing that we'll talk about is reference variables. Okay, so what are reference variables? Reference variables goes like this. You may have like int, float, string, bool. These are called primitive types. In other words, they are easy data types. Just a number, whether it's a whole number or a decimal number, some text or true or false. These are easy data types. We call them primitive. And when you think about, like, if I say x equals to 5, in your mind, this picture should appear. You have a variable x, has some memory allocated to this variable, has a value of 5 in it. That's it. Because the data is so simple, the data can stay in the small box allocated to this variable. That's the idea of primitives. Now, what is a reference? References are used to handle objects. So what is an object? Objects are complicated data conglomerate. So it has a lot of data associated with it. It has a lot of functionality associated with it. Okay. So for objects, what are objects? For example, lists, they are objects. Later on, we're going to learn about tuples. They're also objects and etc. So for these objects, because they can be very complicated, we can't put it inside the box of these variables like list 1, list 2. So list 1 is the first list, list 2 is the second one. The way that most of the languages, Python, Java, as well as C, so what they do is they say the object is standing alone. They exist in a special region called the heap region. That's what that's where objects stay. Okay. And the variables that you say list 1 equals to that, list 1 doesn't contain this object. What list 1 contains is the address of this object. Basically, it tells you where it is. So if you need to use this object, you just follow the address to find it and use it. An analogy in real life is more like you have a big house in here. Right? The house is very big, so you cannot carry it with you. What you do is you give each house an address in here, a number, street, road, name, and etc. Right? So you give them an address. If you know the address of the house, you can find it. Right? If you go to Airbnb, they are not going to say, hey, here's the house, I'll give it to you. They just tell you the address. And follow the address, you can get to the house and use it. That's the idea. Okay. Any questions about the reference? We call this list 1 a reference variable. Reference variables, they store the address of objects. Okay. All right. So if I understand that, list 1 is holding the address of this object, list 2 is holding the address of this object. If I say list 1 equals to list 2, now what's going to happen here? List 1 equals to list 2, you are basically assigning the value, this is the left-hand side, equals to the right-hand side in here. So the value of the right-hand side is given to the variable on the left-hand side. What's the value of list 2? List 2 is the address of this object. You are given list 2 to list 1. So you are not changing the object in here. List 1 now would hold the address of list 2 in here. So list 1, list 2 will be referring to the same object now. When you do the assignment, the value of the variable on the left side is changed into the value of the right-hand side. Okay. So if you say list 1 equals to list 2, list 1 and list 2, they are now pointing to the same object. Are there any questions about this one? This one is probably one of the most important things about memory model. When you assign one reference to the other, they are now pointing to the same object. Okay. Any questions about this part? All right. So let's look at this one. Okay. What is the memory model? Memory model is how the code would run, When you type in this code, you say Python, this file's name, the code would run and give you some sort of result. But you don't see how the code is executed step by step. So how do you do it? Well, number one, you learn memory model. In your mind, you can easily visualize it. The other way is you can use some tools. And today I want to introduce this tool called Python Tutor. Python Tutor is developed by one of the UCSD faculty. In fact, he is from the cognitive science department. His name is Philip Guo. So he developed this tool called Python Tutor that can help you visualize the execution of a Python code step by step. So the link is pythontutor.com. You just Google Python Tutor, you're gonna see it. So let me show you here. Okay. So this is Python Tutor. You can edit a program. You can type in a program. This is the code you see on the previous slide. The visualize execution. Okay. What you have is you have the coding here, and there are arrows. This red arrow tells you what Python is about to do. You are also going to see a green arrow. The arrow is what Python just did. So if you look at it, Python is about to execute the first line in here. And this is this tells you what is going on in the memory, okay? So the first thing we'll try to evaluate is this line. If you click on next, it's going to tell you what's going to happen after you look at this line. If you look at it, Python just look at this line and it immediately jumped to this line. And this tells you when Python looks at a function, it doesn't evaluate this function. In other words, you can put garbage in here. The function may be totally wrong. Python doesn't care. You just look at this function and say, okay, there is a function called clear list. And if you look at in the memory, this is like something called frames. We'll talk about this in a little bit. And there is an object. In fact, functions in Python are objects. So you have this clear list reference that is pointing to this function. You don't have to worry about this for CSE 8A, but you just say Python remembers there's a function called clear list. That's it. Python would only evaluate this function, in other words, only execute the code of the function when the function is called. Right now, we're about to execute nums equal to 11, 12, and 13. Any questions about the first step? All right, so let's run the next step. We say nums equals to 11, 12, 13. Now nums is a reference, is pointing to this list, 11, 12, 13. Okay, so it tells you at every step what is going on in the memory. The next thing we're about to do is clear list. So we're calling this function. Once you call function, I want you to observe in this region, the code would change, the memory would change a little bit. I'm about to call the function. I'm calling it right now. You see a new blue region is created. This region used to be blue. It is no longer blue. What does it mean? When this region is blue, it means it is active. When it's not blue, means it is dormant. So what do you mean a new region in here? When you call function, a new room is created for that function. We call this one a frame. A more precise wording is stack frame. So this function now has a stack frame. And if you look at it, this LST, the list is pointing to the same object in here. Why? Because when you call function, the value of the arguments are given to the parameters. Nums has the address of this list, and that address is given to LST. Now, LST contains the address of that list. That's why LST is pointing to the same list here. Okay. Now we are about to execute this code. When you execute a function, all the variables you created in that function would be living in the room allocated for that function. In other words, in here. So we're about to execute the for loop. First, I created this index, right? IDX has this value. Because of the range, right? The length of the list is 3. So range 3 give me 0, 1, and 2. So IDX would be 0 to start with. And then I say list 0 minus 1, which is list -1 equal to 0. We do have a element in here, 13, whose index is -1, right? Remember negative indexing. So basically, after I execute this line number 3, this 13 would be changed into 0, as you can see. And then you go back, run the loop again. At this time, index will be 1. List 1 minus 1 equal to 0. So this element, list 0, will be wiped to be 0. Run the loop one more time because IDX will be 2 now. List 2 minus 1, which is list 1 equal to 0. So this 12 will be wiped to be 0. Now I'm done with the for loop, right? This loop would run 3 times. Indeed, it ran 3 times. Now I'm ready to return. It tells you, okay, this function is going to return. Since it doesn't have an explicit return statement, it's going to return none. So it's going to go back to wherever it was called. Once a function returns to its caller, the room you allocated for this function will be destroyed. So once I click on next, you see this region disappears and this global frame becomes active. But as you can see, this list is already changed. Used to be 11, 12, 13. Now it's all 0. And that is the memory model. That is the memory model. Any questions about how to use Python tutor or the process that we just explained about this program? Any questions? So in our quiz, in our exam, feel free to use Python tutor if you are stuck to help you. Okay, although you may not have a lot of time to say, I'll type in everything in Python tutor and do it, right? But it's a good tool for you to analyze what's going on in here. All right. I didn't see any questions in the chat. Okay, let's look at some exercises. Okay. So I have this list and I'm calling updates, and updates is a function. It does something. What, and then I print out the list. What will be printed out? Let's vote in. Okay. All right, it looks like we disagree with each other quite a bit in here, right? Right, we'll stop the vote. If you look at the vote, A is the most popular one, but every other choices are there. Let's look at it, right? How does this work? You got to think about it in the memory model. So you have this function, right? You have this function. The first thing Python does is look at this function and say, okay, there's a function called updates that takes something. That's it. The first line, the first real line that it will run is this part. So this part is not part of the function. So everything in here belongs to this global frame. So name is a reference. It is pointing to this list of Paul, Y, Chao, right? And then I call the function updates. That's when I trigger this function call. But this global frame is here, and then all of a sudden a new frame is created for this updates. This updates has its own parameter called name. And let me see, where's my mouse? Here. This name and that name, those are totally two different variables. They may have the same variable name, but they are totally two different variables. Just like two people may call Paul, but those are two different persons. You know. So in this situation, the value of this variable is given to that variable. In other words, the name, the value in here, which is the address of that list, is given here. So this name will be pointing to the same location. Okay. And then we are starting to say name 0 equals to Shannon. Name 0 is here. So this is become Shannon. This one becomes S. And then Chao didn't get changed. And then the function is done. So the update part is done. And then when you print it out to the list, you're going to see Shannon S. Chao. So the answer would be A. Okay, the answer would be A. Any questions about this part? So it's not B, C, or D. You have to follow the memory model.
May you please explain one more time again why Chow is included as well? Because I originally said C, and I'm still a little confused as to why Chow still gets included in what's printed.
Why do you think it doesn't? Why do you think it got deleted?
I would just think because we're printing updates name and Chow wasn't defined in updates name, and I'm just not exactly sure what the logic is behind how it gets included if it wasn't printed in updates name.
It was not printed in here. It was printed inside main. So this part, it didn't create a new list. It's modifying an existing list. So,
okay, that makes sense.
Right, it didn't create something new. It's because it's just like let me see. So I have 3 offices. I say you go there and paint it for me. You decide to paint the first one, you paint the second one. The third one is still there. It didn't get changed. So when I come back and check, I see the first 2 got changed. The last one is still there. It just still has that information. You didn't create 3 brand new things. You didn't create anything new in here. You're just modifying an existing list.
Okay, that makes sense. Thank you.
Okay. Any other questions? All right. So I do want to kind of bring up another thing is memory, right? So people sometimes say, when they say memory, what do you mean memory, right? So memory is very, very important. Let me see. For example, okay, if I go to apple.com, is that I need to buy a computer. I'll use Mac. I personally am not a Mac person, but as I'll buy a MacBook Pro, right? So I'll just pick this one, whatever. No, this one doesn't have the spec. All right. Let me say buy. Okay, I'll buy this one. And you're gonna say, okay, these are the specifications of a certain Mac. So it has CPU, GPU, whatever it is. But you have this thing. It's called 8 GB unified memory. I don't even what unified means just burned in, right? You can't add in stuff. But the idea is what is memory? What is CPU? What is storage? This is like the hard drive. That's where you can store your files, you can store videos, and it stays in there. CPU or GPU, they are the one that actually do the math, right? Do the calculations. Now, what this memory really is it supports the execution of your program. So when you buy a new computer, I would say if you have money to spend, right? New computers are very expensive now, but if you say I have some extra money I can spend, do I want to say I want to get a better calculation, or do I want to get better memory? I would always go with better memory, because memories are important. They support the execution of your program. So whenever you have a piece of code, in fact, all the programs that you run on the machine are programs, right? So there are codes in there. So basically, when you say I use Word, I use anything, I use the browser, I use Zoom, you are executing a piece of code. And all those programs, they got assigned some memory to support their execution. If you think about like these programs that are Amazon.com, the website, these memories are like the warehouse that stores the goods. Without the warehouse, Amazon.com won't be able to function, right? So it's very important that you understand why there is a memory component and why there's code. When you execute your code, the memory would change accordingly to support the execution. Just like when someone orders something from Amazon.com, at one of the warehouses, one of the robots would pick up that thing, package it up, and mail it. So the memory would support the execution of the program. Okay, that's one thing I want to make sure everyone fully understand. Memory model means we're looking at the memory, the supporting storage for your program. So when you look at your code, when you run a piece of software, there is this coding segment that actually have the instructions. You do A first, you do B second, you do C. So that's the instruction. There's also this memory region, there is a stack region, there is a heap region. The memory region are changing as you run your code to support the execution of the code. Okay. And that's one of the major goals that we're going to try to build up today. It's just so you get a better sense of how your program actually runs. Okay. Any questions in here? So one thing that I think we can spend a little bit of time on is a few methods that comes with the list, comes with like strings. So whenever you have objects, those objects that are in general packed or equipped with some sort of functionality, in other words, they can do something, you use the dot operator to access them. For example, if you have a string, you say dot strip, it's going to remove all the leading and trailing spaces from that string. If you have a list, you say append another value to the list. You're going to see 1, 2, 3, and 4 in the new list. And we say this is a method. This is also a method. Okay. So look at some of the methods that you may see from lists or strings, just to practice a little bit. Okay. So first thing, what is the value of num? So I'm calling append a few times, and in the end I print it out. What would I expect to see when I print it out? Okay. Vote in whenever you're ready. Okay. I think we have a strong consensus on this one. All right. We'll stop the vote in here. Okay, stop the vote. The answer should be B, right? So 2 asterisk asterisk 2, this means 2 squared. This is 2 to the power 4. So asterisk asterisk means power. So Python would not actually store the mathematical expression. It's just going to store a value. So it's going to be 2, 4, 8, 16. Okay. And this is in general what you do. Sometimes you say, build up this list that satisfies the following requirement. What you can do is you can kind of keep appending data to it, and you end up with the result in here. Questions about this one? Okay. Let's look at this. There is one question. Hold on. Is there any difference from imports other than that you don't have to type import? Can you explain more? What do you mean import something?
I just know like you could import some kind of function. So you could say import rand int and have like some kind of like random value come up. So is it kind of similar to that?
The methods in here, import is more general. So you can think there is a hierarchy, right? When you do import, you are importing a very hierarchy. You are basically importing libraries. This library may have many objects that or class, be more precise. Class and object. So class 1, class 2, class 3, class 4. So this is what you import. In general, when we look at methods, methods are kind of what a class can do. So we're at this level right now. So it's slightly lower than import. When you say import random, you are importing a lot of things that is packaged with random. And the random has a lot of methods that you can use here. Okay, so those methods are these things. And for the list, you don't have to import anything because it comes with Python. It's like the default import. Okay. Hopefully that answers the question. Any other questions? All right. Now, how about this split? When it's ABCD split based on the semicolon, what is the length of this resulted list? Remember, split would split a string into a list using this one as a separator. So how long is it? Quick vote. We disagree with each other a ton on this one. Vote in. Okay. All right, we'll stop the vote. If you look at it, BCE, people have a tie in here. The answer is what split does is to treat this as a separator. Right, so you're separating here, separating here, separating here, separating here. And the things on the side, so this is element 1, A, and the element B, element C, element D, they're all strings, right? But you have to be careful because there's this last semicolon in there, there will be an empty element created. You have 4 things, then you have 5. You have 4 separators. That means you have 5 things, right? So the answer, in fact, would be 5, not 4. Because this last semicolon is the problem that would basically create this empty thing. Just like 2 walls would divide the room, 1 wall would divide the room into 2 parts. That wall is the separator. So if you have 4 separators, that means you have 5 things that are separating from. So that's why in the end, you end up with the 5. So be very careful in here. Okay. Questions? You can split on anything. Okay. For example, you say, let's split based on this symbol. What is going to happen is we don't have to vote on this one. I think you see this is a separator, another separator, you end up with you're awesome. Okay. Any questions about this part? Okay. Now the next thing, I say join these elements using plus. So this is a string. I'm saying connect these elements in the list using this one. So what would you say the result will be? All right, we have a strong consensus on this one. We'll stop the vote. Okay, most of us got this one. It's A, right? So you're just, it's like a separator. You use this plus as a separator to connect them. And that's 1 plus 2 plus 3, right? So that's the join method from a string, Last exercise. Well, you know what? I think it's time for us to take a break. Once we come back, we'll finish this exercise, and then we'll return to our discussion of memory models. Okay. So take a 10-minute break, come back at 12 noon. Okay. So break time, take a break. All right, everyone, get ready to come back. We'll start in a little bit. All right. Let's get started in here. So this is the last exercise about methods, and then we'll return to memory model, talk about stack frames a little bit. So you have this message, and then you split, and then you go through the loop, and what you do in this loop is you are appending these words to the list. In the end, you call join. You want to print out the message. The question is, what will be printed out? One thing I want to point out, you be careful, is this range. Okay. Be careful with that. That being said, let's vote in, please. What would you say the answer is to this problem? Take your time. This one is a little bit tricky. Okay. I don't think anyone has voted in are getting the correct answer yet. No one has voted for the right answer yet. Be careful with that range. Okay. All right, we'll stop the vote. It looks like we didn't get this one yet. If you look at it, the message is live, love, and laugh. We're splitting based on space. So words would have live being the first word, love, and then laugh. Right, that's what we have. And then we say list equals to empty. For I in range of the length of words minus 1, the length of words is 3. 3 minus 1 is 2. So we're looking at a range 2, 0, -1. Right? So what are the potential values for y if this is my range? Remember, we start from the left, which is this is the start. But you don't include the end for range, right? So with the step size of -1, so you start with 2 and then 1, it doesn't include 0. So this is location 2, location 1, location 0. We grab the first thing is the second element from words, which is laugh. We append it to this list. At this time, list would have laugh. And then the next thing I append is love. and it is appended at the end. So what you will see is you will append basically the list would have love as the two elements. If you do a join, it's gonna join them by a comma. So the correct answer is A. Be very careful of this range. Do not make a mistake because a lot of us said D, live and love is not just the first two. This actually is going backward because the step size is a negative value. How did we get range 2, 0, -1? Because the length of words is 3. This one is 3. 3 minus 1 is 2, right? So that's why we get this range 2, 0, -1. And when we look at range, it starts on the first number. And then the next value you get would be this first number add with the step size. And then it's an arithmetic sequence, right? So 2, 1, you basically getting one smaller every time you go. And then you get a 0 in here. It doesn't include a 0, so stop before 0. That's why we have a 2, 1 in here. So the potential values that I would take is, first value it takes is 2, second value it takes is 1. That's why it's love and love, connecting them using joy. Any questions about this? Okay. So that's a small kind of divergent to methods. Now back to the main business today is memory model. Okay. So when you think about memory model, we said, well, okay, every function gets its own room. Every function call would create a new room. And we say that's the stack frame of that function. There also exists something called a global frame. Basically, Python allows you to have codes outside functions. For the codes that are outside the functions, they are supported by the global frame. Okay. So these are some of the descriptions of how stack frames work. Every time a function is invoked or called, a new frame is created to support it. In other words, all the variables that the function they need to create, those variables, they exist in the frame for that function call. The parameters of the function also exist in the frame. When Python is looking at a variable, the first place it looks at is the stack frame that supports that function call. If you can find it, that's the variable it's going to use. But if it can't find it, Python would go to the global frame and try to look for that variable. So the global frame is there's only one global frame. And all the functions, they can access things in the global frame. Okay. So that is the idea of stack frames. Later on, we have a few more slides about how stack frames get created, get destroyed, and some more details. But are there any questions about these concepts? All right, if there are no questions, let's look at one example in here. Okay, let's use Python tutor. I think it draws better than me. Let's see, where's the code? There we go. I'll copy this code into Python tutor, then we can visualize it. Okay. So Python tutoring here. Let's edit this program. So that's the code, and we want to know how things go. If you click on visualize, the first thing is Python look at the function, really doesn't do anything. Start to execute the first line after the function. right? In other words, it's going to run the first line that is not part of any function. So it's gonna run full for. This is a function call because it's triggering a function. When you call a function, you will see a new frame is created to support that function call. So in here, this new room is created. The parameters are in there because I pass in a 4, so num would be 4. And then we're going to run the function code. Whenever you need to access things in this function, it's going to look for variables in this room. If it can't find it, you will go to the global room to look for it. So in here, the first thing I do is num bigger than 0? Well, num is 4, so it's bigger than 0. So it's going to simply return 1. I'm done. So we're about to return value is 1. I go back to my caller. Once I return to my caller, this room is destroyed. You'll see that is gone. Okay. And then coming back in here, this is where I call the function. I go there, I come back. The next thing I do is val equals to 7. I just created a variable. So you see val now equals to 7. Then I'm calling foo again. This function call would trigger a frame. It's a brand new frame. Okay, it's a brand new frame. So come here. This frame has its own parameter num. At this time, num is 7 because the value of val is given to num. Now we are about to execute the code. Is num bigger than 0? Yes. I'm going to return 1. And this return value is simply thrown away. So now I come back here, I'm done. Any questions about this process? All right. Let's look at some exercises in here. Okay. First thing, if I run this code, excuse me, if I run this code, what will be printed out? Let's vote. All right, it looks like a majority of us are getting this one. Very good. We'll stop the vote now. A majority of us said C. Variable is undefined. This X is undefined. That is correct. Okay, why is X undefined? Python would look at the first line. Okay, it's a function. I remember there's a function called setX. I'm done. And then it's going to look at this line, print X. And this is a piece of code that is not part of any function. So basically, this X doesn't exist in the global frame. So that's why you're going to see an error. Okay. Any questions about this? All right. So the takeaway in here is functions do not execute unless they're called. And this is unique to Python. This is in fact a bad thing because if you have a problem with the function and you don't check it until it is being used, your code will crash. Just like you say, I don't check if my car has brake or not. I just drive it. And I will know if my car can brake or not when I'm on the highway. That's a bad idea, right? So Python tried to do this, so it saves some time, but in general, it's not a good thing. But it is what it is, right? So keep this in mind. Python does not evaluate the body of a function unless the function is called. Okay. Next thing. I say set x in here, I call set x, then I print out x. What would you say will happen in here? All right, now a lot of us change our mind. If the 100 will be printed, that's the most popular choice as of now. If you look at it, more than half of us said A. That unfortunately is incorrect. Okay, so you still see the error. You still see the error. Why do I still see the error? You have to follow the memory model. The first thing is you have the global frame. The global frame basically says, well, there is a function called set x. And then you say, I call set x. This is the room created for set x. You created the variable x equals 100 from this function call. Once this call is over, this thing is destroyed. And then you say print x. You're going to look for that x in here. Nothing is in there. So that's why you still see an error. Okay, you are not going to see 100. If you say print x inside that function, yes, you're going to be able to print out 100, but not after you have finished the function call, you have returned to the global frame. Any questions about this part? All right, so variables in the function stack frame only exist when the function frame exists. Once this x is done, it's done. Now, how about this one? Count. Now, this count function, and this is what I did. I call count 3 times. What will be printed out here? We disagree with each other a ton on this one. Well, no, I think we have a winner in here. We will stop the vote in 5, 4, 3, 2, and 1. The slight majority is B. It's going to print out 222, and that's the answer. Okay, that's the answer. So when you call count, you actually go to the stack frame, for this count. In that stack frame, you have x start with 1, x increase by 1, x is 2. When you print out x, you see a 2. And then this frame is destroyed. The second time you call this count, a brand new frame is created. In here, x equals 1, x is changed into 2. When you print out x, you see a 2. Similarly, for the third round. That's how we end up with 2, 2, 2, not 2, 3, 4. Okay? Because every time you call function, a brand new frame is created. Once you are done with that function, the frame is destroyed. In essence, you get a brand new frame every time you call the function. Okay. Are there any questions? Okay, so here are some key points that we'll look at as a quick review. Okay, number one, Python does not evaluate a function until it is called. Okay, so the first line Python would execute is the first statement that isn't part of any functions. That's what we have. When the function returns, the function returns when the last statement of the function is executed. In other words, this function doesn't even have any return statement. Just the last line is run and then we are done, or when the return statement is executed. Either way. A function always goes back to its caller. A function does not always go back to the main stack frame. It goes to the caller, whoever calls it. A function stack frame is created when the function is called, and that frame is destroyed when the function returns. A function can only access variables in its own frame or variables in the global frame. In other words, a function cannot go to another function's frame and do something in there. You can't. Okay. Local variables take precedence than the global variables. What that means is when the function tries to look for a variable, it's going to look inside its own frames first. The things in the frame of a function, they're called local variables. So that's why we say local variables take precedence than global variables. Are there any questions in here? All right. So this is our introduction of memory models. Hopefully these summaries would make sense to you. Okay. I think we have the last topic for today. Are there any questions about memory models in here? All right, then the last exercise in here, the last topic is debugging. Okay, so when you have a piece of program, you say, I want to figure out what's going on, like it doesn't produce the right answer, or it doesn't even run, that's when you're trying to find the problems in your program. Right? All of us will have bugs in our program, and we need to fix them. There are three kinds of programs. There are three kinds of errors in our program. The first kind are called syntax error or grammar error. For example, I forgot a colon in here. I forgot to close the square bracket. I forgot to indent. Those are basically grammar errors, right? Grammar errors are easy to fix. Because just for example, if you say, I'm learning Spanish, and when you speak Spanish as a beginner, you're going to make grammar mistakes. But as you get better and better, you are not going to make a lot of beginner mistakes, right? So syntax errors can be caught by Python. Python will tell you, hey, there's an embedded syntax. It will even highlight it for you. will tell you, okay, line number 3, there is a problem. You go there and you fix it. So syntax errors, a lot of us as beginners will make syntax errors, but also this part is easy to take care of, okay? The second part, the second kind of error are called runtime errors. Runtime errors are like your code runs, there are no syntax problems, but at some point your code crashed. For example, you say nums equals 1 to 0. You say for everything in this nums, I'm going to divide, I will use it to divide, to be divided by 5. So 5 divided by I. When I print it out, when I is 1, I get 5.0. When I is 2, I get 2.5. When I is the last value in here, I get 5 divided by 0. And that's when you see these dreadful error messages. When you have these error messages, the most important thing is not panic, and you look at these error messages. In fact, Python would tell you where the error happened and what is probably the most likely reason it has happened. So it's called traceback. They're saying in this file, in line number 3, you have this thing. Print 5 divided by I. It's a 0 division error. You're dividing something by 0. That's why your code crashed. And then probably you'll realize, oh, I is 0, so I got to do something. So runtime errors, basically your code crashed. And it's bad. Runtime error is bad. So what do you mean? Like if you think about syntax errors, if you think about having a car, syntax errors means your car doesn't even start. You can't drive it. It doesn't even work, right? It doesn't happen often, right? Because if you say you have a car, in general, we assume the car can start, right? Runtime error is like your car randomly breaks down at a certain point. Like you drive on the highway, all of a sudden the car just dies. And Python will tell you why your car died. Maybe it's running out of gas, or it has no electricity if it's an EV, and etc. Right? So that's runtime error. Runtime error is pretty bad, right? Because you don't want to buy a car that breaks down. If I set in your software, you say, my software will give it to you, but it just crashes at certain points, or I don't know why it crashes, it's very bad. No one would buy your software anymore, right? Just like if I'm using Zoom, Zoom crashes all the time. No one is going to use Zoom anymore. Zoom has been a very stable platform so far, right? So that's kind of runtime error. We talk about syntax error. We have runtime error. The last kind of error is called logical error. Logical error are the worst of the 3 kinds. So for example, you have this code, you want to calculate the average of this, and you print out the wrong value. It didn't crash. The average of these values should be like 4 dot something, but it gives you a 5. So why? Your result is off a little bit, but the problem is you have some kind of incorrect assumptions about the code. In other words, you have a wrong logic. And this is the worst. If you think about the car example, for example, the car says, well, I'm driving from my home to a grocery store. The car always drives you to the bank. So it doesn't crash, it doesn't break it down, it just gives you the wrong destination all the time. So that's the problem. To fix the logical error, a lot of times it takes a long time to fix it, because in general, your code runs and it follows your thought process closely. It's just because your idea is wrong. Your idea is wrong. That's when logical errors are the worst, okay? So this is kind of the 3 kinds of bugs. The easiest one is syntax errors. We make syntax errors as beginners, but over time, you're gonna naturally reduce the number of syntax errors. You may see some runtime errors, easier to fix because it tells you where things went wrong. Logic errors are the worst. Okay, a lot of times students ask me during office hours, okay, my code failed this test, and I have no idea why it does it. That basically tells me the student has a logical error. Right? Something is wrong with the student's thought process. That's why a lot of times when the student asks me a question, I always ask back, why do you think that's the case? Because by asking the student the question, I can figure out where the problem is. Because normally, if a student is confused about something, there is this misconception of, okay, the student was assuming this is the case, but that's wrong. I would never be able to figure out where the problem is unless I ask student the question. So logical error is the same thing. You have to kind of doubt yourself. Is my idea correct? Right? So that's why debugging is very frustrating. It's kind of discouraging because you write a code, you thought your code is good, but it just doesn't work, right? If this happens very often, it's just very bad, right? So to avoid spending a lot of time debugging or figuring out what went wrong, it's better that you do good when you design your idea. In other words, maintain your airplane, right? Make sure everything works before you even get started, before you let the airplane fly, right? So that is the best way. Avoid bugs in the first place, okay? You say, well, what if I have bugs? And this is true. All the programs that you write and I write will have bugs. It's just I'm more experienced than you are when it comes to like looking for potential bugs. Okay. So here are some suggestions that you can use to try to find the bugs in your program. Okay. Here they are. Number one, you want to look at your code or go back to your paper and see what are the things that you may have made the wrong assumption about. If your idea looks good, maybe you just didn't implement your idea in code properly. You want to, number one, trace your program, not look at your code, because you look at your code, it always looks right. Okay. So when you trace your program, you want to either use Python tutor or you want to use print statement. You print out the values of variables at different stages and see if this statement runs. I expect x to be 5. Is x 5 at this point? If it is not 5, you know something is wrong with that statement. So that's what you do. You examine the values of variables at certain spots. Okay. Any questions about this? All right. So one rule of thumb, your code always makes sense to you, even if it is buggy. Okay. That's why students always tell me, and sometimes I make them, I will say the same thing. The code makes sense. I don't know why it doesn't work, because the code you wrote the code, right? It must make sense to you because no one would intentionally say, I will just make a mistake in my program. And everyone would do their best in the most logical way they can to write the code. That's why the code always makes sense. Okay. So using make sense or not for the code in general would not help you debug. There must be something that is not working. Okay. Any questions about how you may find the bugs in your program? All right. Let's look at one exercise. I think in our add stem, I have this exercise. Am I writing Fibonacci? So in here, we have the code to find the minimum. I think this is the code. I'll just give you this slide. I think in your slide, you should see the code in there. Can you find out what's wrong with this code? Okay. So this code is supposed to find out the minimum in here, and it doesn't work. It doesn't work. Can you find it out and fix all the problems with it? I don't think there are syntax errors. So there are logical errors in here. I don't think the code would crash. Okay. Let's try to debug this as an exercise. Once you think you fix all the bugs, give me a vote. Okay. You can also use Python Tutor, copy this into Python Tutor as a practice and see if you can get, if you can use Python Tutor to help you to determine what's going on. No one has voted in. We haven't been able to find the bug. This function is supposed to find the minimum of this list. Okay. Try to find the bugs in here. It's 4 minutes. I'll give folks 2 more minutes. Then we're gonna try to work on this together. Yeah. It's best if you eyeball it, right, and see if there are any obvious problems. Once you are able to identify the obvious problems, and you say, I still don't know where things are wrong, then maybe Python tutor is good. Because it does take time to trace through the program, right? All right, last minute, okay. All right, so one of us is done, I guess. All right, so let's work on this together, right? The first thing I want to do is I want to eyeball it and see if there's any obvious problem. So you have the list and then print out the return value of find min. So the result is what I will return in the end. For every value in the list, if result is less than value, in other words, if I see something bigger, I would change this thing. Most likely, I shouldn't be saying val equals result. Probably it should be the other way, right? I want result to be changed. I want result to maintain the smallest that we have seen so far in the list. So probably this is better. And then I will return result. Does this one give me the right answer? You can go to the last and it's going to print out. Ooh, it give me a 10. Looks like it gives me the largest instead of the smallest. So let's add it. So result is less than val. If I see something bigger, I'll remember it. Maybe I should flip it. If I see something smaller, right? I think logically that makes sense. If I see something smaller, I would remember it. If I not right, ooh, give me -2. Perfect. Looks like the code works. Did any of you see any other bugs in here? So I flipped basically this part, give us some trouble. We fixed them. Are there any problems that folks see? Nobody see other problems in here? Let me try to change the tester a little bit. Instead of -2, I say this is 5. And when I'm looking for the minimal, I'm supposed to see 1. When I run it, it tells me it's -1. That's bad. That's bad. Right? So it doesn't work in here. So there's this hidden bug that if you don't test it thoroughly, you're not going to see it. So result equals to something, right? It looks like this -1 is too small for this array. So what should I do in here to fix this problem? Because right now I only have one tester, right? So if the tester is not what I'm looking for, basically the single tester would not be able to test the code properly. Change the result to be 1. Okay, now I run it. Okay, good. But what if I have an array like this? I'm supposed to see a 3. Around it, it says it's 1. Maybe index it to the first value. That's what I'm looking for. That's okay. Result equals to nums 0. Yeah. So will this work now? Oh, now give me a 3. What if I change it to be negative 100? Run it, negative 100. So it looks good now. But what if I give you this? If value equals to an empty list, I run it. So what's wrong? You see there is this red box. It says manage engine. So in here, it says there's an error, index out of range. The error comes from here, in fact. This array is empty, so I don't have the 0th element. What should I do in here? What should I do in here? I probably need to check the length of the list. If this is the case, I'll simply return. If you give me empty list, it has no minimal. And now, if I run it, it says none, it has no minimum value. And this would not mess up other values. 44, 100, and negative 100. It's not gonna mess up anything. So it's gonna give me the right answer. And this exercise brings up the importance of testing your code thoroughly. So I only have one test, it looks good, I submit it. For 8A, we kind of run your code against all the tests, but we don't tell you what the tests are. But if you think about it, if you work as a software engineer, or if you work, say, I work as a research assistant for one of the faculty, and say the faculty said, write a code that process this data set. And you write a code, and your code spit out a number like 7 or 5. How do you know it's right? If you don't test your code thoroughly, you just assume, oh, they spit out a number, then that must be the right answer. Then if your faculty relies on your answer to draw a conclusion, then maybe you guys are leading to a wrong path on the research. Similarly, in the software engineering world, right? If you say, I write a code to identify objects in front of a car, and say, okay, my code said that there is a tree in front of it. I don't verify it, whether it's a tree or not. If you don't test your code thoroughly, your car may simply crash or kind of recognize the object in front of it. So it's very important that you test your program thoroughly. Not just one test, usually 5 to 10 tests. Okay. Any questions? All right. I think we can use our break right now. We have one coding challenge. I think we have time to do maybe a couple more coding challenges, and then we'll call it a day today. Okay, so we're gonna write some code. We're gonna try to test it out and make sure it works well. Okay, so let's take a break. Come back 1 o'clock. We're gonna do some coding practice together. Okay. All right, break time. All right. Let's resume. Okay, let's resume. So the last section, we can use it to do exercises. Okay. So let's get the ball rolling on that. The first exercise is sum 6, 7. Okay. So what I want to do is take a look at it. You are supposed to add up everything in the list except the regions that are guarded by a 6 and the first following 7. That's what we have here. There are 3 examples given, right? So the first part has no 6 and 7, so just add up equals to 5. The second part has this region, and you should skip the region between the 6 and the following 7. It's guaranteed that every 6 will be followed by at least 1 7. And if in here, you add them up equals to 4. These are basic test cases. You must test your code thoroughly in addition to these 3 tests. Okay, so can you write this sum 6, 7 by yourself and give me a vote once you are done designing it? Okay, so write this program and see if you get it. Work on that. Okay. So sum 6, 7. Okay. Well, if it's done, that's quick. This problem is not easy. Yeah, this problem is not easy. Make sure you test your program thoroughly. Okay. So give me a vote once you are done with it. All right, so it's 3 minutes. You got to think. I mean, you should also test your code, right? You can't just say it passed the given tests, it's good enough. You got to test it more thoroughly. What if there are a few more sevens, right? Would your code get the right result? All right, in a few minutes, we'll get started in here. Yeah. These are pretty, I would say, difficult problems to solve, okay? And it's more about the list processing. All right, so let's work on this together. How about that? Sum 6, 7, right? I need to write this function. This function is supposed to return something. Right now, I'm just having a stub. So just return 1, whatever it is. I want to get started with testing, right? So we talk about how to design your idea. So right now I'm designing on paper, right? For example, I say, okay, I'm trying to pass in, I'll say 1, 2, 3, expect 6. And what do I got? I can say I'll call sum 6, 7 by passing in 1, 2, 3. I'll see what I got. And this is one test, right? And then I'm going to start to paste in more tests as I go. Next thing, I pass in this thing. Right? I expect a 5, and I will see what I got if I pass in this array. The last one, these are the given ones, right? So I should definitely test on them. Have that one. Now I will start to create more, maybe like 6, 3, 7, 7. This part should be skipped, but that last 7 shouldn't, right? So the total I'm expecting is 13. I'm expecting a 13. So I expect a 4. All right, or there I expect a 4. This is what I'm expecting a 13. Let's see what I end up with. So copy it in. Now, what if I just give you one thing? I expect a 1. And let's see what I expect. Other things, if I just give you a 7 without the 6, and that's okay, right? Every 6 must be followed by a 7, but if I just give you a 7, I'm expecting an 8. Let's see if I got this one. What if I give you an empty list? If I give you nothing, what am I supposed to say? Or I'm expecting a 0. Let's see what I got. And make sure I double check my error, my tester. This one would expect a 5. This one would expect a 4. This one would expect a 13. This one expect 1. And okay. Maybe I'll test again in here. I'll say, okay, what if my 6 and the 7 is in the very beginning of my program? Will this make any difference? This one I'm expecting an 8. So 6, 7, 1, 6. Oh, I can't have a 6. 1, 5, 2. Right, I'm expecting an 8. What if I have 2 6 and 7s somewhere throughout my program? I say 1, 6, comma 7. And then comma 2, 3, 4, 6, 9, 9, 7, 2. So this part will be skipped. 2 plus these values is 11, 12. I'm expecting 12, right? Because I have two segments of 6 and 7s. Let's see if this one does its job. I think probably this is enough. If I'm able to pass most of these tests, I'll be pretty safe, I would say. Okay. So let's try to run the code right now, python code.py. I don't expect any of them to pass. This one passed, right? But it just happened by chance. No other problem, no other test cases passed. So now I'm ready to solve the problem. How am I supposed to solve the problem? Basically, I need to go through the array, and when I see a 6, I should stop adding the elements to my total. When I see a 7, that is the first 7 I see after a 6, I would resume adding in the values. Right? That's what I'm supposed to do. And if there are multiple 6, 7 segments, I make sure that I take care of them. Okay. So here's the idea. Let's say, I'll say total equals to 0. Right? We need to add up a bunch of things. N equals to the length of nums. And then for each value in this list, what I want to do is I want to check, did I see a 6? If val is the same as 6, I need to have some sort of boolean to indicate whether I'm in the segment between 6 and 7 or I'm outside. So I was call this inside. Inside equals to false. So initially, before I start the process, I'm not inside a 6, 7 segment. If I see a 6, I know I must be inside. Okay. The next thing I want to check is, okay, what if I see a 7? If I see a 7, it doesn't mean that I don't add, right? If I see a 7, it doesn't mean I don't have to add it. What I want to, maybe I should say else if, right? If I see a 7 and I should also check, am I inside? Because if you look at it, if I see this 7 and that 7, those are two different situations. This first 7 match with that 6. This second 7 doesn't. So I should check if I'm inside is also true. In other words, I saw a 6 and this is the first 7 that I see. I say, you are no longer inside. Else, I'm going to add this value to my total. In the end, I will return total. Okay, you may say, what if the list is empty? If the list is empty, this thing would never run. My total would be 0. So should work out. But you never know, right? You never know. Let's run this. Right, maybe I will have bugs. So 6, expect 6, 5. You see, in here, I'm in trouble. Oh, I got 203. This is 4 is right. Oh, in here I got something wrong. 1, 8, 8, 0, 12, we got 30. So if you look at the situation, right? I'm expecting 5. Why did I get to 203? If you look at the math, I'm adding up these things. In here, I've got 30. It looks like I'm adding up these things, right? So something is wrong. I'm adding things that I'm not supposed to add. So if it's 6, I don't add. If it's 7, I don't add. How about things in between? What do they have in common? So maybe I should check the condition if inside equals to false. If I'm not inside, I will add it. Maybe this would work, right? So you find a bug, you look at your logic, and you probably can figure out what's going on in here. If you say, I can't figure it out, that's when you go see a tutor, okay? Or come to see me during office hours. If you look at this one, 6, 5, 4, 13, 1, 8, 8, 0, 12. It looks like we passed all of them. So it checks out. It's not too bad. But you go through it, when you see a beginning, when you see an ending, and this inside would be the marker for you to determine if you add a value to a total or not. Okay. Are there any questions in here? So this is the first exercise, and I hope you can kind of use this opportunity to think about how to test and then how to approach a problem. This part requires some experience, right? You may not come up with this right away, but as you see more and more programs, hopefully that will make you come up with the ideas much faster. Okay. Now, the second coding challenge in here that I have in here is count code. So can you all work on this by yourself a little bit? I'll give you 5 minutes. Okay. Try to come to this slide and think about it. What you're supposed to do is count the number of times the string code appears anywhere in the given string. Except we'll accept anything for the letter D. In other words, cope, who, anything, this would work. Okay. Try to solve the problem. Start with your tester. Start with your tester. Okay. And see if you can come up with this, come up with a solution. Maybe I would say give you 8 minutes. Okay. I'll start the timer now. In 8 minutes. Okay. See if you can get it. So write this code. Basically, the idea is you got to scan through the string. And when you see COE, sorry, CO, and then jump one more letter, you see a E. that means you have seen this string, you increase your counter by 1. I think probably we'll call it a day today once we finish this exercise. Three minutes. Okay. If you're able to solve it, 14. All right, 4 minutes. Okay. Try to come up with your idea. It's a linear scan of the string. Almost 5 minutes. Okay, I think we'll probably talk about it at the 5-minute mark in here. So let's look at this one. All right. So again, I want to get started with testing, right? Count code, or take a like a string, whatever. Let's say word. And right now it's a stub, return 1. And again, you're testing, right? Print, I'll say pass in A C O D E B B B, expect 1. And what do I got? You can call the function count code A C O D E B B B. All right, that's one of them. Now the next thing is I'm passing in this thing. I'm expecting a 2. So there are 2 codes here. right? The third thing, cozy and cope. I'm expecting a 2. And this is what I got. Is this enough? Most likely not, right? So you have to come up with another, for example, 6 more test cases. Now let us try to create them, right? First thing, I said, what if it's empty string? Pass in empty string. I expect a 0. Let's see what I got. These are kind of the edge cases. What if I pass in something that doesn't have any code? I just say A9, A9, pass in this. I'm expecting a 0. What do I get? Right, just passing a random string that really doesn't have a code. A39438. If I have CODE, CO, CE, CO, CE. If I look at something like this, 1, 2, 3. I'm expecting a 3. Everything is good, every 4 letters. Then let's see if I got that, right? Other things including, what if I have a COD in the beginning? Nothing else. I'm expecting a 1. So CODE XXX. Now this part is good. The second test case, beginning and end with something in between. How about I just end? I'm expecting a 1. Let's see if I got 1. So code is in the beginning, code is in the end. And then I just look at COD. Like for example, this one I would expect a 0. Do I get a 0? Right, so it's not long enough. These are, I would say, right now we have like 9 test cases. It should be pretty comprehensive at this time, right? So make sure you double check your test cases. You do not want your test case to be wrong. CODE, that's good. This one is 2. If it's empty string, if this is a weird string, there should be 3 of them. There are 3 of them in here, 1 of them, 1 of them, and 0. All right, so that's it. I got what I tested on, and most likely, I mean, my code will fail, nearly all of them at this time. But now I'm ready to code it up. The idea of scanning a string and look for a certain pattern is very common, okay? It has the same idea as scanning a list. It's basically the same. So first thing, I want to look at this. N equals to the length of this word. If this word is too short, I mean, I can say if N is less than 4, I'll simply return 0, right? I don't have to worry about that. Now, for strings that are longer than or equal to 4, I can start to look at the characters, right? So I can say for I in range of N, I may come back and change it, but for every character in here, I will check if the ith character is C and the next character is O, and not the third character, but a third character can be anything, right? The next character would be E. So it should be word I plus 3 is the same as E. If this is the case, I would increase my counter by 1. Counter plus equals 1. I need to create a counter in here. In the end, I would just return count. Right? I would return count. Any questions? Let's run it, right? I may have mistakes in there. I may not. Let's run it. Python exe.py. Let's check. 1122. Looks like I passed everything. It looks like I've passed everything. And which is weird. I'm expecting an error. Let me see. I in range CO. Okay. I think this one, it looks like I passed everything, right? I think I'm missing some test cases. But it looks good. Let me add a new test case. I know where our test case fails a little bit. It's like this, because this part, I may go out of bound. If I is the last location, then this part is out of bound. So I'll create a test case. I'll create this thing. If I have CO, okay. If this is what I have, I'm expecting a 0. And let's see what we got. Let's run it. Excuse me, I was sneezing. So let's run it. Let's see. The code would fail. The code would fail. It says index out of bound. Why is index out of bound? Because this is C and O. But the issue is this part doesn't have this character, right? If you look at it, I add in C and O, and then the I plus 3's location doesn't even exist. And I'm checking whether it's E or not. This part would give me trouble. And the best way to resolve it is you make sure that this thing is not out of bound. If I plus 3 is the last potential character you have, I think I should be range of I minus 3 or minus 2. You can't let I go to the very end. There should be at least 3 more characters after I. So that means -1, -2, -3. So it should be this. Now it should work, right? Just be careful when you have these indexes that may go out of bound. You make sure you adjust the range. Okay, let's try it. Hopefully this would pass all of them. 1, 2, 2, 0, 0, 3. Everything looks good now. Okay, I may still fail some of the tests if I'm not careful, but I should say I'm pretty safe. Even if you say, hey, I failed this thing, if the whole problem is 100 points, you still get around 90. Yeah. Any questions about this? Okay. So to summarize what we learned today, number 1, we talked about memory model. That's probably the most important concept. How memory frames, how stack frames work. What is the relationship between your code and the program and the memory? And also how to debug. Okay. Then we kind of focus on this linear scan of a list or linear scan of a string. You have to basically manipulate the indexes, and make sure you start with testing. You start with testing here. Are there any questions about these exercises or anything we covered today? Alrighty. I think we can call it today. Don't forget the quiz tomorrow and also work on the PA. Next week, we can have our midterm based on the schedule. Okay. So other than this, we are done today. Okay, everyone. I will see you next week on Tuesday. Okay. Thank you.